Starting. Hey everybody. This is the pre-show. This is the less than 60-second pre-show to Astronomy Daily Live. Hey everybody. It's a bad hair day today, but that's how it goes, especially when one is working on astronomical data. It's just a hair raising day. There we go. 2 hours UTC. It must be time for Astronomy Daily Live. So this is a daily live stream, uh, casual, fun, hopefully um, educational, uh, but also, based on science. So here I am going to be, and we are going to be um, skeptical, yet um, um, open-minded about things. So and yeah, running through the scientific process, because it's awesome and it's very powerful as well. So glad everybody could join. Glad everybody is coming in. Welcome to those who are here, and howdy to those who will be here in the future. Glad you could stop in. Uh, wow, uh, it's been a day of desk work for me. I'm running through this data that I've been collecting recently, and trying to get it all reduced and run through sort of the first set of analyses to see where I stand, and well, we'll see. But I want to make a huge shout out to spacetv. Is it spacetv.net? I thought I was going to be so awesome there. Yeah, spacetv.net. Um, they came on last um, yesterday's show and made an appearance, and that got me, of course, looking over on their site, and yeah, very awesome. I found a couple of different channels that I wasn't aware of. The first one that I'll shout out is called Slooh, Slooh, Slooh. Haven't had a chance uh, to watch any of those shows yet, but I definitely will. That seems like an uh, extremely popular uh, channel. So I will definitely check those guys out a little bit more. And the other one that I checked out and watched a couple of um, um, episodes this afternoon was the Astro Imaging channel, and yeah, I'll make sure to include links to those both in my um, Discord server, uh, and also where else should I put that? Oh, up on my YouTube description, I will put a link to those guys there. Um, and as a result of that, I also found a new um, 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 weather forecasting um, site that is, of course, focused on astronomy. So I'm going to share my screen and we can go over there and take a look at it. I haven't really looked too hard at it yet. So let's take a look. It's called clearoutside.com, and I've punched in the latitude and longitude for a nearby town here. And one of the one of the interesting things that I saw right away was the estimated sky quality. This grayed in area right here. I'm gonna let me let me go to my YouTube channel, see if it's running live or not. It should be. Come on. Come on. Come on, Slowpoke. Man, what is wrong with you? Man, sometimes these machines just drive me insane. Okay, there we go. So this grayed in area is the estimated sky quality for Tucson, Arizona. Okay, and Tucson is a it's not a huge town, but here's what they say about that the the brightness of the sky is magnitude 18.65. It's a class 8 Bortle. Now, Bortle I've heard before, but I don't exactly know what that means. I do know that the smaller this number is, the darker it is. And I think class 8 is probably the brightest. Um, so not very good. Um, I don't know what CDs are. I think these are milli-CDs. I'm not quite sure what CDs are. Candles, I'm not quite sure. Anyway, this is showing 3.74 of those for sky brightness, and then 3,571.34 for the artificial brightness. Now, on my Linux machine, I actually have my location, and it's it just it it brings a big huge smile to my face when I look at the differences. Okay, so Tucson, it says 18.65. Okay, my location says 21.9. Tucson is class 8. My location says class 2. This number is 3.74. My number is 0.19. And this number, 3571.34, mine is 16.88. So that brings a big, huge smile to my face that yes, indeed, I may not have known this before, but now I know for sure because I have the numbers to prove it. That yes, indeed, I live in a very, very, very dark place, and that is literally speaking, and figuratively speaking, and metaphorically speaking. So this is a pretty cool site. Up until now, I've been using cleardarksky.com, or yeah, is it Clear Dark Sky? Clear, yeah, cleardarksky.com. And so let's just go to Clear Dark Sky, and we'll have to go to the Clear Sky charts. Let's just do a quick comparison here, and let's see how close we can actually get to a location. So, of course, I'm in Arizona. Um, I wonder if they're going to have anything Tucson at all. Oh, there is a Tucson one. Okay. So let's look at the Tucson one, and let's just do a side by side and see what this is all about. So today, um, so I'm of course in southeastern Arizona. That that puts me in Mountain Standard Time, and it's always Mountain Standard Time here. Um, Arizona is one of the few locations, at least in the United States, if not the world, that does not submit to daylight savings time, which it's an arbitrary choice. I don't really care one way or another, as long as um, um, we all agree. I don't really care. So as far as I'm concerned, there's only one time, and that is universal time, which right now is 2:09 UTC. But that's of course on the uh, on the 18th. But I'm 7 hours behind that. So my local time is 7:10 p.m. on the 17th still. So it's still Saturday night here, but you folks over in Europe and east of that, it's already tomorrow. So yeah, let's just see. So this goes from 8 a.m. this morning to 5 a.m. on Monday morning. And this one goes from current time, which is 6 p.m., 7 p.m. to 5 p.m. tomorrow. So let's just see. So that's 6 p.m. to 5 p.m. tomorrow. So that would be here, okay, 1800 to there. Am I reading this one right, or is it one more day? Oh, yeah, no, this is just to 5 p.m. 5 p.m. Okay, so way over here. So this says in terms of cloud cover that I should be clear, should have been clear all day today, and then starting to get cloudy about 5 a.m. tomorrow morning, clear up about 10 or so. So let's see. So from 5 to 9, 5 to 10. Okay, well that's sort of agreeing here a little bit. This is saying that I'm supposed to cloud up again at about 1 p.m. in the afternoon, and this guy isn't saying anything about clouds at all. So, obviously, what I'm going to have to do is I'm going to have to, you know, compare these two things to what's actually going on in the sky, and I will do that. That will take some observations, which I have no problem doing. But this has quite a bit of information. Um, I want to investigate this site a little bit more because I don't know where they're getting their information from. This site I've used for years and years and years. It's used all over the world. Major observatories rely on this, and it's based on models that I don't know. Let's see, it's Saturday about 1900 right now, so let's just click on this. This is the cloud cover map of the United States, or at least the Western United States. Now, this is a model. This is not a satellite view. This is actually a model. Um, so this is uh, not actual data. It's just showing, you know, what the computers predict it's supposed to be like. And yeah, so I've sort of relied on this for quite a while. You can't really trust forecasts more than a couple hours out. Um, After that, um, confidence levels in forecasts go way down, and it would be nice. It would be nice if forecasts came with a confidence level, right? Because you know confidence level in a forecast for the next day, it might be relatively high, but confidence level for the next week or the next month might be really low. And I think there's sort of probably two reasons why um, why meteorologists and forecasters don't um, publicly disclose that information. I think the first reason is that it would confuse uh, most people. You know, if you say, okay, there's a 50% chance of rain, and we're 50% um, confident in that. Well, that's going to confuse, I think, most people because they don't have an understanding of what that means. Um, so that's probably one reason. The other reason, which I think is a strong motivation for at least the meteorologists that are on um, TV to not show that that kind of information is because it would show very very clearly how not confident they are in their own forecasts, and you know they want to keep their jobs, right? so so you know if you're consistently um, you know maybe 50% confident in any forecast, what does that tell you about the job you're doing? I don't know. I don't know. I mean, it's not really their fault. It's the fault of the models and the fact that we are dealing with a very, very, very complex system for which we know very little about. Um, Anybody who thinks that they know uh, um, um, what's going on in terms of the weather is screwy, is absolutely screwy. There's nothing wrong with that. There's nothing wrong with that because there's lots of things that we don't understand, we don't know. Um, but to come out and say, "Oh, we're sure about this," oh, that's just BS. No way, no way. So, you know, I would appreciate it if they would publish their confidence levels in terms of forecasting, and I am certain, right, because I mean I understand modeling. I am certain that one of the numbers that comes out of a model is some measure of confidence. Now, before I go any further, I want to pop out my YouTube chat because I'm sure it is just a buzz. I'm sure it is just absolutely a buzz with heated discussions. Yes, there he is, Uncle Bill, always waving madly, waving to anyone who will wave back. Well, I am waving back, Uncle Bill. So hey, nice to see you again. Just just looking at this new astronomical weather forecasting site, and yeah, it gives a lot of information, and I, I appreciate uh, as much information as I can possibly get. I like this wind direction and speed thing. I like that. This is a little confusing. Um, Again, these are based on models, so these are sort of mindless machines putting this information out. You know what? I forgot to fill up my goblet of hydrogen hydroxide, so I'm going to take a minute here and go fill it up from a spigot. I've got a new batch and I'm anxious to try it out. So, hey, give me a couple of just like 30 seconds. I will be right back. All right, hardly gone at all. And Uncle Bill hears me. Cool, 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 cool. So yeah, I thought this this site. Oh, and actually, let me take a big swig of this wonderful, wonderful chemical, hydrogen hydroxide, HOH. Cheers. So this site was found uh, on a site called clearoutside.com. You can set your latitude and longitude, or you can type in an address or a city or a postal code. The one thing that I've noticed so far that sort of bothers me a little bit is is that if I set this default location, I'm not seeing a way to unset that. And I would like to be able to unset that so I can, I guess, I guess the way to do it is just to type in a different uh, city, right? So let's see. Let's do. Uh, where should we go? Let's look at let's look at um, let's look at how about um, Kihei, Kihei, Hawaii. One of my previous jobs brought me to Kihei, Hawaii, couple times a year, and oh, it was absolutely torturous, right? Absolutely torturous to have to go there and work. So I guess I sort of also appreciate the fact that everything is metric, although again, that's sort of an arbitrary choice. As far as I'm concerned, it doesn't matter uh, as long as we all agree uh, what um, um, the measuring device is. I don't really care. Don't really care. So, as you can see, Kihei, Hawaii doesn't change very much. Looks, I mean, it's really fun to watch the local weather over there because the forecast is almost exactly the same, right? It's almost always the same. It's yeah, folks. Well, today we're going to have a low of 21 and a high of 27. And for tomorrow, the low is going to be 21 and 27. And for the next day, the low is going to be 21 and the high is going to be 26. And the next day, it just goes on like that. But look at the humidity, right? Look at this insane humidity, 80%. Yeah, you know, being being a desert rat like myself, when um, when I go into an environment like that, okay, I feel like I am walking through a pool of water. It is just thick. Plus, you know, there's a lot more air down there too. I'm at an elevation of like 4,200 feet. So when I go down to 0 feet, I've got a lot more air as well. So yeah, let's see what we'll go back to Tucson and see what the um, um, humidity is here. So this is saying, well, see now this is a little bit higher than normal because we are actually getting some clouds and whatnot. But you can see while it's clear, the humidity is in the 20s, and that's pretty normal. 20% humidity or less. So I'm sort of liking this site a little bit. As I said, I'm going to uh, look at this a little bit more over the next few days, sort of compare it to what I'm actually seeing in the sky. Um, uh, I'm not seeing things, over on the clear sky chart, right? I'm seeing a measure of transparency, a measure of seeing, um, and I'm not seeing the same kind of thing here. I'm not quite sure what these things are yet. Obviously, these are different days, but if this is just sunrise and sunset, not quite sure what all these other markings are. See, there's these little red things here, little red thing here. So yeah, I have to get into it a little bit more. Not quite sure what the different colors mean. Um, but yeah, looks like a pretty interesting site. But yeah, as I said, I've got to investigate this a little bit more. I just found out about it um, a couple hours ago. So yeah. So anyway, huge shout out to um, to those two sites. I'm trying to pull them up here. Come on. Let's see. There it is. What? I don't have to sign in. What is going on here? New incognito tab. All right, look, I'm just going to exit that and exit that. Sorry about the technical difficulties. There's always some kind of weird technical difficulties going on. So the astro imaging channel, that's just one whole phrase. So if you search for the astro imaging channel, and then the other one is called SLOOH, SLOOH, and I haven't checked any of their videos out yet, but they've got some pretty popular ones, and yeah, it looks like some pretty interesting stuff. And overall, I would say that spacetv.net it really is a pretty cool site, and I'm glad to be on that and a part of that. It's a huge site. I really haven't had a chance to go through it all, but they have news, different live channels, documentaries. So yeah, I'm gonna have to go through these. I really like the font. I like the layout. Although the layout is, I think, just sort of the standard now. But yeah, I like the font. I like the look. Um, seems pretty easy to navigate around. I like it. I like it. So in fact, I don't know why I'm not. Let's go over here. Spacetv.net. I've been looking at it over on my Linux machine, and you guys can't see that. Oh, that's funny. They asked me a picture that I wanted to, sort of associate with my channel over here. And so I pulled up, my favorite, or I immediately thought of my favorite Messier object, M37. No thanks. And and so I said, hey, pull up a picture of that, and they looked around a little bit. I guess couldn't find anything they were satisfied with. So this morning I went on to the Gaia website and went into the database, pulled out all the stars in a 30 arc minute field of view, which is the size of the moon, centered on um, Messier 37, and plotted all the stars in the correct position, and then wrote a little script to just connect all the dots, and put some color on it, and blah 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 blah, and sent them that, and it looks cool. It looks cool. So I think that'll do for now. But see, along the top here, you can look at news and different channels, documentaries. Here's all the live things, and it's kind of funny because since I'm a daily, um, uh, uh, so Astronomy Daily Live pops up like constantly, constantly, because it's on every day, right? So it just like almost has completely taken over. Space radio is a good one too. Paul Sutter, he's a smart dude. I like it. Deep Astronomy, of course. Tony over there, killing it, absolutely killing it. Weekly Space Hangout, Fraser Kane, yeah, yeah, awesome. I recommend all of these, all of them. Watch them, learn stuff. They're very very awesome. Anyway, should I show my artwork over here? Sure, why not? So here it is. Let's see, can I find it? Oh, I don't know why it does that. I try to scroll up. There it is. So if we look at the original, it does that, but I made it really, really big. I made it like 4,000 by 4,000. So if if you zoom in anywhere, you can actually see that it's just a bunch of lines with a bunch of dots. And of course, the dots are the stars, and the size of the dot is the brightness of the star. So the dot, the brighter the star, and I just connected all the dots. That's all I did in this. Come on. Let's see, we can scroll over to the side over here. Can we do that? Yeah. Oh, yeah, yeah. It's just fun. It looks much better unzoomed, I think. But and then I put sort of a dark blue background on there. But yeah, that's just the location of um, M37. Now, one of the things that this live stream does want to cover is astro-art. So that can be visual art like this, audio art, um, any other kind of art. There's a um, at least as far as I'm concerned, there's a huge relationship between science and art. And in fact, um, I'm big on changing STEM, STEM, which is science, technology, um, um, engineering, and mathematics. I want to add an A in there for art. So STEAM, and I think STEAM is is such an awesome concept because STEAM is also one of the most amazing molecules in the universe, right? And uh, and so I just like the connotation there. Um, all right, well, enough of all that. I was just very excited to find this new site, um, and they were nice enough to um, get me hooked up in here. So yeah, that might actually bring in a larger crowd, which would be awesome. This is um, just a circle of friends who share a common passion. You know, getting off the TV, getting away from the news for a while, and talking um, all things astronomy for an hour or so, and it's awesome. I also appreciate the fact that space TV uh, also realizes that there is only one time, and that is UTC, right? So here it is. It is ticking off, and yeah, we're already into minute 36 of Astronomy Daily Live. So let's see. Let me check the chat. Make sure that there isn't a rash of activity. No, I don't really see any. Let me go over uh, to the live chat server. Make sure that there's nothing too wild going on over there. Doesn't look like it. Doesn't look like it. How are we doing for? Uh, let's stop sharing for a second and see how we're doing in terms of viewers. Yay! Very cool. Glad to have you here. Let's Oh, come on now. I don't know why we have to be such a pain. Screen share. So I thought what I would do is come over here and look at this. I thought was a pretty interesting paper. Just came out last week. Data as a research infrastructure. So, I mean, we're getting into a situation where we just have tons and tons and tons and tons of data. Okay, hold on 1 second. I have a kitty to deal with. Hold on one second. The kitties are definitely the masters in this house. We are just doorman. That's it. So yeah, it's this whole idea of, you've got all this data, right? And it's only going to get more and more and more and more, right? And so the whole idea is that scientists love to share data, share results, uh, all of that, right? So they've created things like IVOA. Um, so yeah, I was just sort of going through this a little bit. It seemed interesting too that at least according to information somewhere down here, yeah, the uh, um, the astronomical database I like to use, Simbad, um, apparently gets like 800,000 queries per day. So that's just insane. It's just insane how much. And as I said, it's only going to get more and more and more and more. It's awesome though. It's awesome, to be able to sit here, practically in the middle of nowhere and have access to, all these surveys and all this data. And it's absolutely fabulous. And it's data at any level, right? I mean, if you just are looking for um, some kind of a pretty um, um, picture, to share with friends, um, you can find those. If if you want, raw data from Juno, the spacecraft, uh, you can find that too, and everything in between. And it doesn't have to be um, um, image data, right? It can be magnetometers, it can be spectrometers, it can be, you know, particle detectors, just anything at all. And it's all, um, freely available. And so I can sit here in the middle of nowhere and actually do, real scientific investigation. um, it's awesome. It's absolutely awesome. So this paper is just, sort of laying out uh, what's going on in terms of all of that. And I really didn't get a chance to read through it. I was hoping that there would be some pictures because I love pictures. Let's see, networking and interoperability. Short description of Simbad already demonstrates the astronomical online services are networked. Yeah, because Simbad, as we already know, uses Vizier. Where to go? Vizier, NED, ADS. It's awesome. It's awesome. Uh, uh, let's see, the Astronomical Virtual Observatory. Um, Around 2000, the idea to go beyond this already powerful networking resources was by providing seamless access to online data emerged as the virtual observatory concept. IVOA was created in 2002. Current status of the virtual observatory. So there was just a talk given at CFA, um, um, the Harvard group, the Center for Astrophysics. So check out their YouTube channel for that. It was something titled like, um, the VO is alive and well. And yeah, it's just, the VO now is just sort of trying to set standards for data. So, the whole idea there is that there isn't going to be sort of a central um, server where all this data is fed into it and fed into it and fed into it. It's just, if you have data on your server, on your um, um, machine, and want to have it accessible to the rest of the world, why don't you set the data up such that it has certain structures, certain metadata, certain formats um, that allow the VO to hook into. So when people want that information, the VO can go out to your server and grab it. And I think that's brilliant because then you, you don't have a centralized place, and that is awesome. That makes it robust and um, and then you as sort of the holder of that data can take care of it and be responsible for it. And I think that's awesome. It it doesn't require bureaucracies to take care of things and to back things up and to do all this and all that. It's up to you, and I think that's great. You decentralized, fantastic. But yeah, we're talking lots and lots and lots of data. The um, uh, yeah, very very soon we're going to be in a situation where there is going to be terabytes of new data every single day. Um, LSST is talking about millions of of um, um, alerts every single day. So and an alert is some kind of transient event, who knows what, right? Millions of these every single day. It's going to be madness. It's going to be absolute madness. You know, we thought for a long time that things in the sky really don't change all that much. Well, the only reason why we thought that was because we weren't looking. If you start looking on small time scales of, minutes or hours, it's like, holy shit, there's a whole bunch of things going on up there all the time. And it's insane. It's totally insane. So, yeah, the next 10 or 20 years is going to be absolutely amazing. So let's see, the notion of management and research infrastructures. Da, 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 Raya, Claren, many different disciplines organize themselves to tackle the development of their disciplinary interoperability framework was discussed during a session of the SciDataCon 2016 conference. Panel included representatives from that. Development of data infrastructure must be science driven. Defining the disciplinary part of the interoperability standards is mandatory but difficult. It's important not only to share data, but also tools, um, user interfaces. Yeah, yeah. Sociological aspects are more challenging than technical ones. Huh, that's kind of interesting. Research Data Alliance is a community-driven international organization created in 2013 by the Australian government. Those Australians, man, they're fantastic. They're um, in so many ways they are just out in front. 5,900 members. Wow. Okay, I'm gonna have to check these guys out because I've never heard of them. There's a lot of things I've never heard of. So there's not an astronomy group in the RDA because okay, yeah, because of course it would replicate that. Um, let's see. I don't see any pictures though. Boy, that just makes me mad when there's no pictures. What kind of paper is this without pictures? I don't know. Not even any references. No references, no pictures. Actually, it looks like there are some spaces for references, but they this is either a not quite finished paper yet that somehow slipped out, or I'm not exactly sure, but you know, where there should be like a reference, there's just a question mark. so so I don't know what exactly that means. Now, see, sometimes there are like these number 17. Is there a number 17 at the oh there is. Okay. So that's just a link, it looks like. So there are there are links, but yeah, see, there's a couple others where there's just no references. No references at all. So, oh well. Let's see. I'm going to go back onto my live stream. Browser crash. Did you miss much? Uncle Bill, you missed the most important thing. Remember in Forrest Gump when he's like, this is what I have to say about Vietnam, and he started to talk, and they pulled the mic thing on it. Okay, that's how much you missed. You can't miss any of this. It's you know, it's yeah. You're just gonna have to go back and listen. That's all. But that's one of the cool things about a live stream, right? Is if you um, miss it now, oh, we'll probably talk about it again in a day or two or three or a couple months, whatever. All right, so that was a pretty interesting paper, I thought, and I do have a link to that on my Discord server. There was another one here that well, I'm pretty excited about these fast radio bursts. Fast radio bursts is sort of the latest in sort of the weird things going on in the sky, and fast radio bursts are exactly um, what that says. It's a radio burst, and I think for the most part they're able to locate it, um, but they happen extremely fast, extremely fast. Let's just pull up this particular paper, and for the most part, these things seem to be popping off all over the sky. I think there's only one that has actually occurred like twice, I think, in the same place. And so nobody understands these at all. But I'm going to come down here and you can see. Let me zoom in on this plot here. Okay, so what this is showing is this is the time in milliseconds. Okay, thousandth of a second. Okay, and here's the burst. There it is, right there. It seems to happen, along um, sort of a frequency band. So, but the whole thing, right, lasts a very, very, very short period of time. On the order of tens of milliseconds. And so, but these guys have um, uh, been able, to sort of uh, get some really, really nice time resolved uh, um, time resolution. So they have a sampling time of 327 microseconds. So that's like point point 0.3 milliseconds. Uh, and I'm trying to understand I'm trying to understand exactly how long burst burst lasts. Um, Detection filter, S peak, width 400 microseconds. So maybe that's it. Oh, maybe I don't know. Let's go back and see. I'm not as prepared today as I would like to be. Let's read the abstract because the abstract usually has a lot of the useful information discovered in real time. Okay, so they discovered this in real time. Discovery was accompanied by the capture of voltage data on the native time frequency. This dispersion measure. I don't know what PC per cubic centimeter is. Ooh, bad news. Burst width at 10% maximum is 400 microseconds, making it one of the narrowest FRBs. Burst shows 3 temporal components, the narrowest of which is 30 microseconds, and a scattering of 4 microseconds. So yeah, these are just complete mysteries, I think, at this point. Nobody really understands what's going on, what they are, where they're coming from. But I guess they're starting to get an idea of their structure. So, they're able to sample these things fast enough now to get, a little bit of info. So let's see if there's any more neat pictures. I always like to see pictures. Okay, so there's one. I'm gonna have to zoom out a little bit here. Okay, so coherently dispersed with dispersion measure, discernible structure is seen at the highest available resolution. So yeah, see, I mean, they're seeing structure now, temporal structure. So, this is a brightness here along the y-axis, and then time along here. And it's got some interesting structure in it. So I don't know. I don't know. Gonna have to we're gonna have to sit back and see what's going on there. Possible small Magellanic Cloud origin. So the extension of localization arc given intersects with the central regions of the small Magellanic Cloud. Okay. Galactic latitude. They're just trying, to zero in on a location, and it's, these things happen for, you know, microseconds. So it's just really, really hard. You got to be looking at the right place at the right time, and you've got to have, multiple instruments doing that. So yeah, that's just insane. Astronomy is just insane. I love it. But it looks like they're narrowing it down. They're building models that seem to match these shapes really, really well. So hey, I'll have to. I definitely want to read through this paper a little bit more because it's. I find fast radio bursts very, very interesting. I'm I'm sort of a transient junkie anyway, so I like the transient events. So I have no idea what this is showing at all. This completely baffles me, but I really like the pictures. They're they're pretty interesting looking, although I don't understand them at all. Recorded a fast radio burst discovered in near real time. This demonstrated our ability to trigger voltage capture. Okay, good. Low latency. The full width of the burst is 400 microseconds. Um, don't know what PC per cubic centimeter is yet. I don't understand what those units are. We'll find out. Um, they have some kind of a spectrum on it too. It's probably like a temporal spectrum. Shows 3 components. So it shows 3 components. I'm gonna I'm gonna sneeze. I'm gonna sneeze again. Oh, excuse me. Microstructure visible in the temporal profile is very similar to that seen in another one that seems to be repeating itself. So what is going on there? I don't know. Currently upgrading. So yeah, they're hopefully, with this new information, they're going to be able to uh, detect these things and make more measurements. The one thing that I haven't really found out about, and I think I just need to research it a little bit more, is how often do these fast radio bursts occur? I mean, are they happening like on time scales of seconds, or of minutes, or of hours, or of days? You know um, how often do they pop? I don't think introduction says much about that. Um, yeah, see, so they've only detected 30 of them since 2007. Um, uh, so how many is that? That's about three per year at this point. So, but yeah, I don't know, what the estimates are. I don't know. I'm pretty interested in these, as you can probably tell. So I'm going to try to dive into these a little bit more. I am in the process of reducing my data that I collected with my system back on the evening of the 15th. So I'm trying to run through that now, and you know, writing some scripts, to make the process a little bit easier. Um, Preliminary look at um, the photometry is I'm scratching my head a little bit. So it yeah, I think I'm trying to understand what I'm I'm seeing in that I'm not seeing um, uh, um, the accuracy that I would like to see, and so I'm trying to understand why. And if I can't, I can't, right? But I think I can. I think I can. So I'm going to continue looking at that, seeing exactly how I'm making the measurements, making sure that the data is being properly reduced. The reduction looks good though. It looks pretty good. I'm subtracting off the darks. I'm applying um, the flat field. That all looks pretty good. So it's just the actual flux measurements. Um, when I compare those to Gaia, the accuracy just isn't quite what I was hoping for. So going to continue to look at that, try try to understand a little bit more about what I'm doing. Just make absolutely sure that the kinds of measurements that I want to make are actually what I'm um, doing. I've only looked at one image out of uh, many, out of a lot. So right now, right before this um, live stream, I just measured a bunch of fluxes from 20 more um, images. So I'm going to look at those and do a comparison and see. if those are saying, the same kinds of things as this first image. Um, the one big difference between my system and Gaia is that Gaia is measuring brightnesses of stars uh, at one particular wavelength, um, um, one particular band pass, and my system, I was wide open, so I wasn't filtering at all, and so that's going to change my measurements of magnitude, because I'm looking at all the light as opposed to just um, a narrow band of light. So um, they were looking in the green. So if a star is excessively red, doesn't have a lot of green light in it, then to Gaia, it's going to look faint. And to me, it's going to look, whatever it is. So when I compare those two, I am going to see differences. So I have to be able, to figure out a way to compensate for that. And I think I can. Those kinds of things are done um, all the time. Cheers. So yeah, that's just a ongoing process with more images. I I'll be able to nail down my precision, which is just a measurement of consistency, right? So if I look at the same stars over 50 images or so, and I get the same number each time, then my precision is really really good, and that at least is going to make me a little happier than what I am right now. But the accuracy also has to be very very good, because if I can't measure the actual brightnesses of stars, then uh, either I'm doing something wrong, or uh, there's something else that I'm just not doing right. Who knows? Who knows? Still up in the air with all that at this point. As I said, I am taking you along on this journey. Um, the I'm just trying at this point to sort of um, parameterize the performance of this scope in my CCD camera. Um, Hopefully, uh, to an interesting end, which is actually just going to be a beginning of a pretty exciting project that I'm hoping is going to go, but it depends on me being confident that I'm going to be able to deliver the goods, because that is the most important part of this um, project. So if it turns out that measuring in the brightnesses of these stars with no filtering at all isn't a good idea in order to do a comparison, then I'll put a filter on it, and it's not going to be the exact same one as Gaia, but it'll be probably closer. So yeah, we'll see. I should be able to transform all these things, though. Figure out what the mapping is between those two things. We'll see. Tomorrow is another day. And speaking of tomorrow, I think it's time for me to, yep, yeah, it's time for me to get back up to the ship. I've heard the call, so I'm going to get out of here for now. Um, so far, so far, my experience has been that tomorrow has arrived. So probably there's a good chance, very, very, very good chance, that I will again be here tomorrow, 2 hours UTC. Make sure to subscribe if you haven't already. Make sure to share this video and this channel with those who you know may like this kind of content. Hit the thumbs up, hit the thumbs down, whichever you prefer. Make some comments if you like. Um, Check out the links down below in the description. And yeah, I think that's it for now. I'm going to get out of here. Hope everybody has a great evening, a great day, and I will see you on the spin. All right. Have a great one. Peace, cheers, and all that good stuff. All right. Bye.